In this video I'm going to look at a second example of graphing inequalities. And just to quickly kind of run through the steps of graphing inequalities. So step one is to graph the equation, but just remember that if you have a greater than or less than equal to sign, you're going to use a solid line. And if you have a less than or greater than sign, you're going to use a dashed line when graphing the equation. Once you have the equation graphed on the coordinate plane, step two is to test a point on the coordinate plane and determine if it is a solution. And then step three is to shade the area where the solutions fall. So that's going to either be inside the area or outside the area, depending on whether or not your tested point was a solution. So just kind of looking at this example here, example 2, I have y is greater than or equal to x squared plus 2x minus 8. So I can see right off the bat, based off the sign, that I'm going to use a solid line to graph. And then I can also tell that this is a quadratic, so I should have a parabola, and this is in standard form. So to find the vertex of a parabola in standard form to be able to graph it, I'm going to end up taking the opposite of b all over 2a, and then I plug that back in to the function to find the y value. So opposite of b over 2a will give me the x value, plug that back in to find the y. So in this specific example, I'm going to end up taking the opposite of b, and if you remember, really what a, b, and c are, they're just the coefficients off of the quadratics. So right now my a would be 1, my b would be 2, and my c would be negative 8. So in this case, I'm going to take the opposite of b. Well, b is 2, so the opposite of it is going to be negative 2. And then that's going to be all over 2 times a. Well, my a is 1, so 2 times 1 is 2. And then if I simplify that, that's just going to be negative 1. Now once again, that gives me the x-coordinate of the vertex. I still need to find the y-coordinate. And to find the y-coordinate, I have to plug in the x-coordinate back into the function and solve for the y. So in this case, I'm going to get y is equal to negative 1 squared plus 2 times negative 1 minus 8. And negative 1 squared is just 1. 2 times the negative 1 is a negative 2. And then if I subtract 8 from that, well, that's going to give me 1 minus negative 2 is negative 1, minus 8 is a negative 9. So my vertex is going to be at the point negative 1, negative 9. Now, once I have the vertex, I usually want to start by graphing that. So I go negative 1, and then I'm going to go down 9. So my first point is right here. Maybe I'll label it with a V just so I know it's the vertex. And then after I get the vertex labeled, my next step is to use my A to find the next 2 points. So right now my A is equal to 1, and I will put that over 1. You always put the A over 1, and that'll tell you how much you rise when you go over 1 unit on your graph, starting at the vertex. So for instance, if I start at the vertex and I go over 1, well, I'm going to go up 1. And then if I go over 1 the other direction, I'm going to go up 1 as well. So the A kind of tells me when I go over 1 and up 1 where I'm going to be at. And then lastly, I might want to know, when I graph this, where am I going to cross the x-axis at? Like, where are my x-intercepts at? And to figure out where the x-intercepts are, I need to know what the solutions are to this quadratic. And if you remember or recall from earlier lessons, in order to find the solutions to a quadratic in standard form, we need to factor it. So if I go ahead and factor x squared plus 2x minus 8, and I want to solve this for where y is 0, because that's going to tell me where I'm at on the x-intercepts, I can really factor this as x times x, and then I can think of this as plus 4 and minus 2 equals 0. And then at this point, we can separate these into x minus 2 equals 0 or x plus 4 equals 0. So either x is going to equal 2 or x is going to equal -4. And this is going to tell me where my two intercepts are. I'm going to have one at 2, and then I'm going to have one at -4. So my graph is going to curve upwards like this, running through those two x-intercepts. Now, the last thing to check is one that you drew the line right, so it should be solid, so I'm okay with how I drew the line. And then the last thing is I want to check a point to see if the solutions are on the outer region of the parabola or if the solutions are in the inner region of the parabola. And normally the best point to pick is always the origin if you can, and that's the point 0, 0. So for instance, if I plug 0, 0 into this equation, will I get a true statement or will it be false? Well, if I plug 0 in for the y, I'll get 0 is greater than or equal to. And then if I plug 0 in for the x, 0 squared is just 0. 2 times 0 is going to be plus 0, and then minus 8 on the end. Well, is it true that 0 is greater than 0 plus 0 minus 8? Or in other words, is 0 greater than or equal to -8? Yes, that is true. So in this case, I see that it is a solution. It's also on the inside of the parabola. So all my solutions are going to be on the inside of the parabola. So this area here would be my solutions.